1, 2, 3, 1, 1, 1. Hello, hello, hello. Hopefully everyone can hear me who is trying or already joined the streaming today webinar that will be focused on one of our new gadgets that is called SPI Lamp version 2. There are a couple of new features that I've already talked about on the previous webinar, and this time I would like to cover the more advanced stuff that is available with the gadget. Once again, I will ask you if you can hear me properly. If not, we can always tweak the sound settings a little bit. And also there is a chat available on YouTube where you can type in your messages, and we will be more than happy to answer those as soon as possible. Probably I have a colleague already on chat also, and he may be also be able to write the answers to your questions. As I've said, today I will be talking about the SPI Lamp version 2. If we can switch onto the table then, just tell me when there are any questions. It's this little gadget over here. SPI Lamp is a signal splitter and output multiplier. And as you can see, I've got a lot of stuff today on the table prepared. And I also have the LED Strip Studio software running on my PC. And together we will map what I have on the table. I will show you how to use DMX dimmers in pair with the SPI lamp, and also the advanced connection with the standard digital strips. So I have all this ready. This time I don't have a presentation to quicken everything up, so hopefully it will be interesting. The stream will be available on YouTube after, so you will be able to check that out. I assume that if no one wrote already that there are any questions in regards to the sound quality, then we can jump straight into what I have prepared here. So I will show you what I've got on the table exactly. I've got 4 SPI lamps here. 4 SPI lamps, and to each of the SPI lamp I have connected one of our lady dimmers and a small piece of an analog RGB strip. The reason is that with the new version of the SPI lamp, you can output the DMX data from the output. Basically what you can do, you can multiply your outputs not only for digital pixels but also for DMX. With the standard version of LEC3 or SPI Matrix for that matter, you already have an option. If you can switch to me, Ben. You already have an option to output DMX from the SPI outputs. So one of the ICs that you can select in the web config is DMX, and that is both for 3-channel version and for RGBW, so 4-channel version, which is a great feature. However, we are limited to only using the one output to you've got one universe available, but if you will connect more pixels, more LEDs to it, then you are done. The SPI lamp solves this. The way that you can connect up to 6 SPI lamps into single output of the SPI Matrix or LEC3 and use the whole universe. So that is 512 channels or 170 pixels. So the option was already available with our controllers. Now with an addition of SPI lamp, you can connect up to 6, as I have said, to a single output. And that way you can use the whole potential of the universe, of the DMX universe that you have available. A very quick overview of what you can see on the display of SPI lamp. The lamp, Ben, the table, thanks. So a very, very quick overview what you can see on the display, which is another additional new feature. You can see currently selected IC. That is all the ICs that are available in the web config you can select on the display. You can see the number of LEDs that is connected to your output of the SPI lamp. Also what you can read from the display. So we can turn this. Hopefully that's visible. This is the voltage that is currently present on the output, so you can double check before you connect your LED pixels, digital or analog, whether you have proper voltage present on the device, since you can not only send the data through the SPI lamp, but you can also power your pixels or your LED strips. So it may be a good practice to double check before you will connect your your pixels to SPI lamp, to double check whether there is correct voltage present on the SPI lamp, and also there is available a current firmware of the device. With the previous version of the SPI lamp, you were able to update the firmware through the SD card and through the controller. This option is still available. However, there is a new option that you can upload the firmware directly to an SPI lamp from the device, from the web config. So you don't have to upload it one by one. So which is also a great feature, and that is why you have on the display information of what is the current version of the firmware. Once again, a good practice is to keep an eye on what is the current firmware and update it as much as possible, because we are constantly adding new ICs, support for new chips, I mean, and cleaning out the bugs and stuff like this. So always look out for new updates for your firmware for the controllers. If we will go back onto the table, so that is the display. You've got the buttons that you need to control it. You've got your power in for the SPI. One, 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 1, 2, 3, 1. We are back. Sorry for this. But apparently we've run out of space for recording, so the software decided that they will just quit on us. So hopefully you can still hear us properly and see us properly. We can run a small double check whether everything is visible, so we can go then through the table and the PC. Yes, and can you hear me? You can double check on YouTube whether you can hear me also, but you can. Awesome, great. So once again, sorry for this technical issues, but I think that we've solved it, and yeah, still any questions, let us know. I was talking about the SPI lamp itself. So I've shown you the ports, the display, the buttons that you can use, and then the ports for the data in, data out, and also the port for the data for your LED pixels or dimmers or DMX strips itself. All the info, all the important information about the device itself you can find on our page. Also there you can find the data sheet and the, not yet Ben, also there you can find the data sheet on our page, and also the manual, which I strongly recommend to double check whenever you will have an option, or before, and this is very crucial, before you will start to work with the SPI lamp. So I can show you where to find it. So you'll go onto our page, and either you can go into shop or you can go into products, LED accessories, and there is an SPI lamp. For those that want to buy it, head to our eShop. And for those that want to just check what are its capabilities, go into the product page. And there you can find the manual. With all the important information. So go ahead and double check whether it will be suitable for your project. There is the pinout for the output, as I was saying, and also the pinout for your power input, and all the LEDs are explained here, basically everything in regards to this little gadget. And you've got, and this is very important and probably also a good example for you to double check before the installation, what is the typical connection scheme with a SPI lamp and how you can use it. So a good source of information for everyone that wants to start with it. The controller that I have here on the table is an SPI matrix, which is upgraded a little bit. It is activated for the for the LSS software, so you don't have to use the ArtNet license or ArtNet data, but you can use our custom protocol for LED Strip Studio software. And also it has, as you can see on the back side, instead of Phoenix connectors, standard green block terminals, it has RJ45 for outputs, which is perfect for or in pair with SPI lamp, since you can use standard Ethernet cable to transfer the data over a long distance. This is another advantage of SPI lamp. You can send the data over really long distance. 100 meters is perfectly fine to send the data from the controller to your SPI lamp, and also between the between the gadgets. So you can very easily, and you don't have to worry about it, use an Ethernet cable that will be 100 meters long, because we are sending differential data. So I've got this controller, a couple of SPI lamps, and the controller comes with the web config. And the web config is a super important web page built into the SPI matrix or LEC3, where you can set up everything in regards to the controller. Currently I am in the settings page, and I wanted to show you what would be the first step whenever you start to work with your SPI lamps and SPI matrix. You will try to test out whether you have connected everything properly. So you will turn on, for example, red solid color for testing. And it is currently, as you can tell from the status, outputting something. The same you can tell from the little LEDs flashing above the output itself. And you can also tell on the SPI lamp that there are some data coming in. But as you can't see any red lights flashing on the LED pixels itself, and you can see all the LEDs flashing on the SPI lamp itself, it means that the data that it's receiving are not correct. For that, you can go back into the web config, and since we are using for this part of the webinar LED dimmers, we want to output DMX data, which you will set on the SPI lamp itself. But whenever you are sending the data from the controller to the SPI lamp, you have to use our custom protocol. We are only using the first output, so other three we can leave as it is, the settings. And we have to set in the output the type of the output to LSS strip RGB or RGBW, and the second version. You can also find in the list the first version, LSS RGB, somewhere, yes, here. And this is for the previous version of SPI lamp. And perhaps some of you want to ask whether they are compatible. They are unfortunately not, so you have to use a discrete protocol for each one of those. So for the second version, you will use as a strip RGB, and we can play red dimming. And if we will check on the table, our pixels are already flashing. Since I have already set on each one of these SPI lamps the proper IC, which I can show you perhaps on this one. So I am in the menu IC, and there I have selected the IC17. If we will go back into the web config and we will click on this little icon here, IC17 in the list is DMX RGB. The same number, same index that you can find in the list in the web config, the same index that you can find here, you can find also in the list on the SPI lamp. If I would change this to, let's say, 13, the animation, the testing pattern will stop working. That is because I am sending incorrect data into my output. So I have to revert it back onto IC17 and it's back flashing. We can also try different testing patterns. So yeah, we can stay on Mi Ben. That's okay. Perfect. We can also try different testing patterns. So green, blue, everything is set as it should be. If you would hit red solid and you would have green, for example, that means that you have to change the color order in the web config for your output. But since everything is set up properly, we can go then into the software. I have a blank new software opened. So I have a blank new software opened. I will just do one more thing, and that is I will stop the test pattern, because otherwise that testing pattern will take priority over the software. As you can see, it's already in an Ethernet mode. That means that it's connected to the software. First basic thing that you have to do is to, in the mapping, search the device that you want to work with. I have already added this SPI matrix I have on the table manually. So you will hit plus, type in the IP, and you are good to go. It's also indicated by this little green icon over here. Since you have two options in the software to add digital or an analog strip, be advised that whenever you are using the output of the SPI matrix, the SPI output, you are not working with analog pixels and you are not adding it into this table over here, but you are working with digital pixels. This digital pixel or digital strip over here, we can call DMX, since we will be outputting DMX data. And I can draw a single line that does not have 60 pixels in it, but only one, right? Because this is not an addressable pixel. This is analog strip. So you can't control every individual pixel, every individual LED, but you can control only the whole segments that are connected to your dimmers. So I will leave this to 1, and I can, in the software, add or assign my strip that I have drawn into my controller. You can check that in the type of the output or the type of the IC, it's the standard TM or WS strip that all of you are already familiar. I have to change that into, again, LSS RGB for SPI Lamp version 2. I want to double check whether I have selected the proper IC and if I have connected my SPI lamp to my output. So for that, I can select a highlight color, select red, for example. And if you will check, this is my red, which obviously is not. So I have to, in the software, set the proper color order as well. So in the software, we will switch G and R. And now I have proper red. If I will select green now, for the highlight color function, I mean, then the segment will be green. But I only have one segment, right? I want to connect all four, or connect, output the data to all four segments that are here on the table. So for that, within the single or the same strip that I have marked DMX, I will add another segment. And you can see on the table that immediately as I have drawn it, it started to shine up in color green, because that is the highlight color that I have used. And I can continue. That would be my third segment. And I have 4 in total. So this is my fourth segment. Since you are setting up the color order for all segments or all strips within this single LED strip, you don't have to change it for each and every SPI lamp that is connected. We can add a little bit more color into this by going into the software, selecting video scene, and there you can see, although I have drawn the lines, here you can see those as points. So we can add a color effect, a linear gradient, and choose something with a bit more color. And as you can see, it's already playing. It's a little bit too fast, and since I am using the video scene, I can change the speed. And go very slow if I want. So yes, in the software you can use the video effects to play on your analog LED pixels, if you are using the SPI lamp in combination with, for example, Lady Dimmer, which is the small dimmer that I am using. On the SPI lamp itself, you can see, thanks Ben for not showing my bald head, on the SPI lamp itself, you can see once it starts to receive the signal, on the display, the direction of the signal as it is flowing into the SPI lamp. So it goes into this data in, or this port, which is data in, and outside from this port, indicated by this animation over here. If I would switch it, then the animation will go the other way. And also it's indicated by this little green LED that this is the input. So this is the version where you have for each dimmer, right? For each dimmer, you are using one SPI lamp, which can be good for some projects, for some installations, but perhaps you want to use it in a different way. And that is, you want to connect multiple dimmers into single SPI lamp. We can do that, but we would have to tweak a little bit with the settings of the SPI lamp. Right now, on each SPI lamp, if you remember, I have set how many pixels there are. We can go back into the menu, and in here I have the number of LEDs set as 1. That is because I have one dimmer connected to it. If I want to connect multiple dimmers into single SPI lamp, I have to set how many pixels, that is how many dimmers I have connected to that SPI lamp. And I will show you that right now. By the way, the scheme for this cable you can also find in the manual. We are using Ethernet cables for the transfer of the data, the differential data, and also for DMX quite a lot, since it's very available, very affordable. And if you are using Cat 6 or Cat 8 or something, then it is a shielded cable with which you don't have to worry much about the interference. Yeah, so this is a very good option whenever you want to transfer data on a long distance or if you want to transfer DMX data. So the scheme for this you can also find in the manual, so make sure to check that out. I can put that back in and I can take my Ethernet cables and connect one dimmer to another. You can see that the animation stopped. And now I can go from my first dimmer, which is still playing the animation, to my second dimmer. Hopefully. And then to the next one. And as you can probably already see, the pixels are playing the same animation. Right? So if in the software, if you can go quickly into the software bin, if in the software you can see in the preview that the animation is a linear gradient going from left to right, on the pixels itself, it's playing the very same animation. That is because you have to set on the on the dimmers the address. And also you have to set how many pixels you have connected here. So first we will connect these together. And then on the SPI lamp that we have our multiple dimmers connected to, we will set how many pixels we have there. So we will go into the, not this menu, but this menu, LED, and we will increase the number to 1, 2, 3, 4, because that is the number of pixels, that is the number of dimmers that we have on the table that we have connected, and that is the number of basically pixels that we have connected. So we have set this up, but still on the small segments you can see the same animation flashing. So it's not a gradient. That is why, that is because you have to set also now the address on the dimmers. I have a little cheat sheet somewhere. Here it is. So in order for the gradient to go from left to right, we have to set 1, 2, 3 on this dimmer. 1, 2, 3. And that would be 2 and 3. Yes. And then on this segment we have to set address 2, 4. And that's it. Right? So whenever you want to connect multiple dimmers into a single SPI lamp, which is one of the use cases that you can use the SPI lamp for, then you make sure that you set how many pixels you have connected, that is how many dimmers, to the SPI lamp. So in the menu you will increase the number accordingly to how many dimmers you have here, and then you have to set the proper address on the dimmers itself in order to play the animation or the gradient that you will create in, for example, LED Strip Studio software. Are there any questions, Ben? Perhaps the most common use case that, can we switch, Ben? Perhaps the most common use case that you can use the SPI lamp for with this option to output DMX data is to use DMX pixels. So those are pixels that can receive DMX data directly. You don't need any dimmer because most probably it's hidden on the PCB itself. So you don't need the external dimmer, but you can connect it as it is into the output of the SPI lamp. Just make sure that you will follow the proper pinout of the pixel, and also if you will have a proper voltage present on the SPI lamp, if you will decide to power, obviously, the pixel from the SPI lamp. But yeah, probably this would be the most common use case. You will use the pixel that can already receive DMX data, and you will connect it directly into your SPI lamp. In that case, you are not using the dimmer, so make sure set up the proper number of pixels connected to it. So that would be on the display, the menu LED. Also make sure that you selected proper strip type, so you selected proper IC. You can double check in the web config which one you should use, and also it's not limited only to RGB, but also to 4-channel pixels or dimmers. So RGBW you can still use with the SPI lamp version 2. We can perhaps play one more animation. To double check whether I have this properly connected. And it seems that I have. Okay. So this would be the use case for the DMX, whenever you want to work with analog pixels in pair with the SPI lamp. I have also prepared a couple of short segments of digital strip. By the way, if you want to see the very basic settings and very basic introduction of the SPI lamp version 2, the previous webinar is available on YouTube, so go check it out afterwards. And this time I would like to try and show you how you can use another advantage of an SPI lamp, which is that you can output the same protocol that you are sending from the controller, that is LSS protocol 2. You can output that onto the output of SPI lamp. And that would allow you, if we can switch to PC, in the scheme, that would allow you to do or to create this type of connection. So you don't have to go from one lamp to another using the RJ ports that are there, but you can connect multiple SPI lamps onto the output for the pixels itself. And you can create these tree-like structures from the SPI lamps. So let's try to do that. We can get rid of the dimmers and of these connectors. Since we don't need the dimmers, because we can connect straight into our SPI lamp. We can put this away. One quick tip whenever you are working with the small LED lady dimmer and there is a frame stuck, you can play a demo mode and it will disappear. And since I don't want this to shine, I will turn it off like this. And we can put this to the side. So I will just quickly double check it. What is the maximum distance between controllers and transformers? If you can just expand a little bit on what the transformer is, I would appreciate it, because I'm not sure if you can switch to me, Ben, because I'm not 100% sure what the transformator is. Perhaps the power supply unit? Let me know, please, in the chat. So the maximum distance between your controllers, if you have multiple SPI matrix controllers, there is a built-in switch on the device itself. So you can use up to 100 meters of an Ethernet cable to connect the two. Or if you will go through a switch, then the distance can be even longer. If you are asking what can be the maximum distance from the controller to the SPI lamp, then there is also, or the same limit can apply, 100 meters. Although we even tested longer distances with a standard Ethernet cable. Remember, we are sending differential data, so yeah, you can send it on 100 meters without any worries, and you can even test longer distances whenever you will need or whenever the project will require it. You can find in the manual also what we recommend. There is 100 meters, but you can definitely try and test even further distances. 100 meters will work. The distance from the power supply unit, if that was the question, I'm not sure, to your LED strips depends on how thick of the cable you will use, how much power you want to go through the cable, and yeah, if you need to find out, for example, how many power supplies units and power injection points you need to use for a 12-volt strip, there is a small calculator on our page where you can input how many meters of strip with certain number of pixels you want to use for your project, and it will give you the exact number of power supply units and how many power injection points you have to make. But if you have a very specific question for a specific concrete project, write us on WhatsApp or send us an email, and we can give you a very educated, not guess, but the exact what you should do. We can help you with the scheme and everything. Yeah, so let us know. If I was right, probably, is it explained any further, Ben, the question? What the transformator can be? Mm-hmm. No? Okay. So hopefully I answered. If not, write in the chat, and hopefully I will be able to explain it further if I will be able to. Let's go back onto the table, where we have to make a couple of adjustments. The strip that I will be using for the second part of the webinar is 12 volt. So let's double check whether I have 12 volts on the SPI lamp, since I will be powering it directly from the SPI lamp. So that would be an IC, no, and I have 12.1. So I'm good to go. I can connect my pixel strip in here. Also, by the way, sorry, you can find the pinout on the back side. So if you don't have the manual available, you haven't printed it out, or you haven't memorized it, then you can also double check the pinout on the back of the SPI lamp. So as always with our devices, on the output it goes ground, clock, data, and plus. Ground. This is the strip with backup. So the backup is shorted on the ground. And yellow is my data, so we can go in. And we can do this with the remaining SPI lamps. Okay. Remember that I have set in the IC, on the SPI lamp, or in the IC menu, that the strip type that I am using is DMX. So I have to change it. So again, we will go into the menu, select an IC, and we'll go all the way down to IC2, I think. Let's double check the web config on the PC. So this would be standard TM, yes. Okay, and we can do the same on my second SPI lamp, IC, not 17, but 2. You can see the red LED means that it's receiving the data and also sending it all to the output. The same we will do with our third SPI lamp, all the way down to 2. And the last one. I have the software connected, but before, as I mentioned, it's a good practice to run test patterns. So we can go into the web config, hit red solid, for example, and so yeah, with this we can double check the color order, but also if we will hit red solid, we can check currently how many pixels that are set on each SPI lamp. So remember, on this one we've set 4 pixels because we had 4 dimmers. So we have to change this to a proper number. So we will go in the menu in LED and watch as I will go up. I'm also increasing the number of pixels. And it says 15 on this single output of the SPI lamp. The same we can do very quickly on the second SPI lamp. Again, also 15. This, by the way, is a box that you can use to protect the SPI lamp. Since it's plain PCB against the elements, you can download the file to 3D print your own box. It's definitely available in the shop, and you can also write us on WhatsApp and we can send you the files so that you can print it for yourself. Previously, SPI Lamp did not have any case. You were only able to hide it inside a standard electrical box, which you can still do with the new version, but also we've designed this little box where you can hide it. So go and check it out and print it for yourself. Number of LEDs on this one is again 15. Now we can stop the test and we can go into the software. Here we have previously prepared the mapping for the dimmers, right? So we have only set in the mapping that each and every one of the lines that are drawn in the software only has 1 pixel, which is not the case, obviously, for digital pixels. They are individually addressable, so we have to increase for each and every line to number 15, because that is the number that we have set on the SPI lamp itself. You can do that with your mouse wheel, or you can type in the number. The strip type that I'm using in the software as the output remains the same. It's LSS strip 2 RGB version for SPI LAMP2, so you don't have to tweak with that, because previously you were setting only on the SPI lamp that it is outputting DMX, but from the software and from the controller it will be always LSS protocol, remember that. And we can double check this with the highlight tool. Everything seems okay. And the animation is running. Can perhaps change the direction a little bit. Much better. This is the standard use for the SPI lamp, right? You have one connected after each other, and you have a certain number of pixels connected to the output. So you have set on the output what is the IC of the pixel itself. But as I've shown you, you can create this connection where you will set on the IC of the SPI lamp. Don't output TM1809 or WS2815, but output the LSS protocol on this connector. So we can do exactly that on or with second. Yes, on this one. You can, by the way, use the very same cable that you've used for the DMX. Again, the scheme in the manual. We can double check in the web config what is the proper IC. LSS RGB, so it's 33. We will disconnect this, use the cable, and set in the IC number 33. So this would represent the Y diagram or the tree diagram, sorry, that you can also do with the SPI lamp. Obviously, you've got still an output available on this SPI lamp. So you can connect more SPI lamps in the line, daisy chain more SPI lamps in the line, and use this output for the data for the next SPI lamp. And, of course, to this SPI lamp, you can connect onto the output another one. So this way, you don't have to daisy chain the gadgets one by one, but you can daisy chain them, or you can create this tree-like structure, which can be great for certain types of projects where you don't want to go in a single line, but you want to create this tree-like structure. Any questions in regards to this, Ben? Okay then, since we are already 1 hour into the webinar and into the presentation, I would like to thank you for joining. Once again, I would like to mention it is available on YouTube, so you can check it out after it will be finished. You can write us on WhatsApp and basically any other social media. You can follow our Instagram, where we post every other day a short video about how to work with digital pixels, analog pixels, our controllers, our software, and how to work with LEDs in general. So it may be a good source of information for you. And also on our page, there is this menu available where you can book a free consultation with us. You can select whether you want a free one or paid one. We will have very gladly a short chat with you about your project and try to propose a solution for your installation that we think would be best for your work. So go ahead, hit book free consultation and select in the calendar that will pop up your free slot. Also on the page, in the support section, you can find a wiki, which is full of articles in regards to our controllers, our software, what strip types are available, and yeah, there is a lot of information here that you might find useful for your projects. If you decide to buy anything, go into shop. And I think that is it. Thank you very much again for joining. Any additional questions, let us know. And in 2 or 3 week time, we will have another webinar that will be, we will send out an email what would be the topic. If you have any ideas on which topic you would like us to cover about our controllers, or perhaps just about how to install LED pixels or work with LED pixels, let us know and we might add it into the webinar. Thanks again. One more time, no questions, Ben. Enjoy the rest of the day and see you later. Bye.